Hello and welcome back to the tutorial. In this video we are going to talk about vectors. In order to create a vector in R, we use the z function followed by parentheses and the values we want to store in the vector. In order to save the vector to an object and give that object a name, we just enter the name and this assignment operator less than minus. So let's run this line of code and we can see in our global environment we have created a vector with the values 1 to 10 in it, and it has the name num.vec. Obviously it makes sense to give your objects in R somewhat descriptive names so you can later recall what is in that vector or also other objects later on. As you can see, I have written a comment at the end of this line using the pound sign. Everything that is written after the pound sign is not evaluated by R. We can have those kind of comments in line with another command, or we can also have them in separate lines. It doesn't matter. They're never evaluated. If I try to run this line of code, it will just skip those and run the next possible line that is actually evaluated. Here I have created a character vector using the same function as before, but instead of numeric values, I have entered characters. As you can see, in order to be able to enter characters, we need quotation marks. Another possible data type are logical. As you can see, the true and false values are kind of blue shaded. That indicates that those are not evaluated as characters, but as logical values of true and false that R can interpret in that way. And we can also create vectors with different types of data. Here I have created one that has some characters and also some numerics. We could also mix that up, it doesn't really matter. However, we're going to see that this is not very convenient to do and it won't really work, but we'll see that later. In order to check the type of data that is saved in a vector, we can call the class function and use the name of our vector as the function argument within the parentheses. And if we call, for example, class of num.vec, we get that this is a numeric vector, as we expected as we entered numerics. The character vector that we saved has the class character. The logical vector has the class logical. Of course, in this example, this is very easy and we already kind of know what the type of data is, but sometimes R makes mistakes or we save some inconvenient values, as we have done in the mixed vector where we have both numeric and characters. And then we're not very sure what the class of this vector is going to be, but it's kind of important to know as other operations depend on the class of the data. So let's check the class of the mixed vector. And as we can see, this is also just a regular character vector, which is kind of surprising as we also have numerics in here. But if we check in our global environment, we can see that even the numerics are in quotation marks. So they're just converted to characters. That is the case because we cannot save two different data types within one vector. And generally, the data is always converted to the more general type of data, which is usually character. Since both characters and numerics can be interpreted as characters, but characters cannot be interpreted as numerics. Now, Usually we also want to access our data in some way, and if we want to print out in our console right here all the values that we have saved in a vector, we can just call the name of the vector, and we get back all the values that are saved. In this case, 1 to 10. We also have a little 1 here, which indicates that this has only one row, which is, of course, because it is a vector. But later on, we're also going to talk about matrices, and then these numbers here are going to be more important. We can also print our character vector, logical vector, and the mixed vector. And here again, we can see that also the numerics are interpreted as characters indicated by the quotation marks. It is also good to know how many values are in a vector. Of course, here we're using short vectors, so it doesn't really matter, or we could easily count them. But theoretically, we can have millions of values in those, and therefore it is convenient to just easily be able to check the length of the vector, and unsurprisingly, we can just call length, and as an argument of length, we use the name of the vector. So, for example, we see that the mixed vec has 6 values in it, and if we check that out, yes, it has 3 characters and 3 numerics, so 6 values. We can also print specific values within our vectors. If, for example, we want to print only the 4th value, we can call the name of the vector followed by the square brackets and the number, or the number of the value that we want to have. That is, in this case, the 4th value. And if we run this, we get back 4, because this is the 4th value in our numeric vector. We can also print a range of values. For example, if we want to get the 1st, 2nd, and 3rd value in a vector, we can type 1:3 in the square brackets after the name of the vector. So here we want to print the first 3 characters of the character vector, and we get back A, B, and C. Thank you very much for watching, and see you soon.